G. Limits at infinity. To find the limits at infinity, we must release the fact that if n greater than 0, then A. Limit x approaches positive infinity for the function 1 over x to the power of n equal to 0. When limit x approaches negative infinity for the function 1 over x to the power of n equal to 0. Look at the graph. For limit x approaches positive infinity, x approaches positive infinity, y approaches to 0. So, limit x approaches positive infinity for the function 1 over x squared equal to 0. When limit x approaches negative infinity, y approaches to 0. So, limit x approaches negative infinity for the function 1 over x squared equal to 0. When x approaches 0 from the right, 0 from the right, and y is increased. So, limit x approaches 0 from the right for the function 1 over x squared equal to positive infinity. When x approaches 0 from the left, 0 from the left, y is increased. So, limit x approaches 0 from the left for the function 1 over x squared equal to positive infinity. When finding limit x approaches plus minus infinity for function fx over gx, where limit x approaches positive or negative fx equal to positive, negative infinity, and limit x approaches positive and negative infinity gx equal to positive or negative infinity, then we will have to divide the numerator and denominator by the highest power of x in the denominator. Note that infinity over infinity is an indeterminate form. How to find the limit at infinity? For polynomial function, we can solve by using factorize the power of x. For example, limit x approaches infinity for the function 2x to the power of 4 minus x squared minus 8x. When substitute infinity in this function, we get infinity minus infinity minus infinity. So equal infinity minus infinity. It is called IDF. So to solve this question, we can factorize the power of x. Limit x approaches infinity, we can factorize the power of x here. Okay, x to the power of 4 times 2 minus 1 over x squared minus 8 over x cubed. And then substitute infinity in this function. We get, and substitute infinity at x to the power of 4, we get infinity. And then times 2 minus 1 over x to the power of 4 become 0. Minus 8 over x cubed becomes 0. So we get equal to infinity times 2. So when infinity times 2 equal to infinity. For the rational function, we can find limit at infinity by using divide each term with the highest power of x. For example, limit x approaches infinity for the function 2x to the power of 4 minus x squared plus 8x over negative 5x to the power of 4 plus 7. When substitute in this function with infinity, we get here is infinity minus infinity plus infinity. Divide by negative infinity plus 7 equal to infinity over negative infinity. It is called IDF. So, to solve this question, we can divide each term with the highest power of x. So, the highest power of x we can refer at denominator. At denominator, the highest power of denominator is x to the power of 4. So, divide each term with the highest power of x referred to denominator is x to the power of 4. Okay, now, each term can divide by x to the power of 4. To x to the power of 4 divided by x to the power of 4 minus x squared over x to the power of 4 plus 8x over x to the power of 4 over negative 5x to the power of 4 over x to the power of 4 plus 7 over x to the power of 4. From here, limit x approaches infinity, we can simplify. We get 2 minus 1 over x squared plus 8 over x cubed over negative 5 plus 7 over x to the power of 4. Okay, and then 1 over x squared becomes 0, 8 over x cubed becomes 0, 7 over x to the power of 4 becomes 0. So we get 2 minus 0 plus 0 over negative 5 plus 2, so equal to negative 2 over 5.